Question 6, we are given a triangle with three vertices, P, Q, and R, and we don't know some details about R. We need to find the value of the little r when the triangle has a right angle at P. If there's a right angle at P, we know the two lines, the two sides of the triangle that meet at P, have to be at 90 degrees, which means the gradients of those two lines are right angles, and they either, you can take one as the inverse negative of the other, or you can say they multiply to -1. Right, so we're working with the gradients of the lines between the corners. We should find the gradient PQ first, because PQ is a definite value. And so the gradient of PQ is 6 minus 2 over 8 minus 0, the change in y over the change in x, which equals a half, which then means the perpendicular gradient is the negative inverse of that, and so the half will become -2. That is the perpendicular gradient to PQ. So now we can say, all right, so the right angle at P, the other line that comes there is PR. So let's find the gradient PR, which is going to be, we can take 6 minus r, the change in y, over 8 minus 2, the change in x. And we know that this equals -2 because that's the perpendicular gradient. We'll bring the 6 from the denominator up to the other side and get -12. And let's take r over to make it positive, and take the -12 over to make it positive as well. And we'll end up with r is 18. And that's the answer. For part 2, we are finding the value of r when there's a right angle at Q. So we're going to use the two lines PQ and QR. Well, we already know PQ, we worked out that gradient was a half, so the inverse negative is again -2. So let's find the gradient QR, and the gradient of QR is 2 minus r, the change in y, over the change in x, which is 0 minus 2. So we'll have 2 minus r over -2 is equal to -2. Bring the -2 up, 2 minus r equals 4. Take the r over, bring the 4 over, and we'll get r is 2 minus 4, and then r is -2. And so we finished the second one as well. For part 3, we are told there's a right angle at R. Now R has got the value that we don't know, so we're going to have to find two gradients which use the point R, and since they're at right angles, either one is the negative inverse or they multiply to -1. In this case, it might be easier to say that they multiply to -1. So let's find the gradient of RP. RP is going to be the change in y, which is r minus 6, over the change in x, which is 2 minus 8. I'm using the point r first this time. And let's multiply it by the other gradient, which is going to be RQ, which will be r minus 2 over 2 minus 0. All right, so we're multiplying the two gradients, and because they're at right angles, they're perpendicular to each other, they multiply to -1. Okay, we can put those two fractions together and get r minus 6 times r minus 2 in brackets over 2 minus 8 is -6 times 2 is -1. Let's bring the 2 times -6 is -12 up and multiply it by -1, and we'll get 12. And let's expand the brackets. We'll get r squared minus 6r minus 2r plus 12 equals 12. Okay, there's a 12 on both sides. Subtract 12 from both sides. We get r squared minus 8r is 0. Factorize the r out. R times, in brackets, r minus 8 equals 0. Now we use the null factor law. Therefore, r is 0, or r is equal to 8. And we're finished. The final part is part 4, which says the triangle's isosceles, and we're told that RQ is equal to RP. For it to be isosceles, the two sides of the triangle must be the same length. So what it is asking us to do is to find the value of r, the little r, when the distance RQ is equal to the distance RP. All right, to find the distance, we do the square root of the change in x squared plus the change in y squared. But since we're doing the distance equals the distance, and we're doing a square root equals a square root, we can just square both sides straight away, get rid of that square root sign, and just do the change in x squared plus the change in y squared. Right, so for the first one, we're going to have RQ, and the change in x will be x minus x, so 2 minus 0 squared, and the change in y is r minus 2 squared, and that's going to equal the distance, which of course we've squared it to get rid of the square root sign, rp, which is going to be 2 minus 8 in the change in x squared, plus r minus 6, the change in y squared. Okay, if we look here, we can expand the brackets. The 2 squared becomes 4. R minus 2 squared is r squared minus 4r plus 4. 2 minus 8 is negative 6 squared is 36. And we've got r minus 6 squared is r squared minus 12r plus 36. There's r squared on both sides, so we can cancel that out. And we are left with just a single variable on either side, negative 4r on the left, negative 12r on the right. I'm going to bring the negative 12r over to make my variable r positive, which means I'm going to take the constants 4 and the other constant 4 over to the right hand side. And if I do that, I will get negative 4r plus 12r is positive 8r, and that equals 36 plus 36 is 72, and 4 plus 4 is 8, and we take it over, we subtract 8 from 72. That of course gives us 64. We divide both sides by 8. R ends up being 8, and we have finished the question.